This video takes a look at a slightly different method than the AC method, one that I think is, well, first of all, easier to explain. Certainly quite a bit easier to see where it comes from. The other thing is it tends to be quicker. Once you've practiced with it a few times, it tends to run quite a bit quicker. But this does rely heavily on mental math. If you've got to whip out a calculator for this, it's not going to be quicker at all. And it might be it might better benefit you to work with the AC method or factoring by grouping. I do have videos on both of those, and if you want to do a search on YouTube for AC method of factoring, that will take you to that method. And I will also post factoring by grouping, which is the more traditional way. This is going to be kind of like factoring by grouping, but I won't have to physically go through the grouping aspect. And a student had taught me this before that she had learned in high school, and I thought, well, this is definitely worth exploring because it's so much quicker. All right. So now, suppose that a trinomial is factorable into two binomials. If it's not, then this method fails and you just won't be able to come up with numbers that work. However, if we go back here and we say, if a trinomial is constructed as a product of two binomials, it is factorable. All right, this statement assumes that it was constructed. So basically, I'm saying, here are my two, ax plus b and cx plus d. If I do that, that's the same as this. Okay, they're equal. And so effectively that says in math terms, it is using the symmetric property of equality. And I'm saying that if I go forward over the equal sign plus AD plus BC, if you, and I highly recommend you do, go ahead and expand this out on your own just to verify that this is what you come up with. When you could, this is, by the way, the result of this AD plus BC term. That's the result of combining like terms. I need to have the coefficients, and that's the coefficient. All right, so now the symmetric property of equality says you can simply reverse these. And so that's ACX squared plus quantity AD plus BC x plus BD, okay, is equal to AX plus B CX plus D. And this is the symmetric property of equality. All right, and so if trinomial was constructed as the product of two binomials, like so in green, it is factorable, which means you can go backwards. Okay, this is a statement that is a theorem, that you must prove it, and that the proof is by symmetric property of equality, you can go backwards at the end. Okay, so now let's take a look at how this was made, because the secret into this is kind of hidden, but not really. It's hidden right in front of your nose. What we do know is that we know that the middle term is made up of the sum of mixed factors. Okay, by mixed factors, I mean grouping tells you that you multiply the coefficient and the constant coefficient. If we do that, we get the number A, B, C, D. And when we factor those out, we have to find two numbers to add according to the second sign to get the middle term, A, D, and B, C. Okay, so you're saying, all right, but that's, yeah, so what? All right, well, suppose I have something like, let's take a hardcore example here. I want to make sure it's factorable, so I got to look through my previous examples here to make sure that this is factorable. So I've got one here, 2x squared minus 3x minus 2. 2x squared minus 3x minus 2. All right, so now, how do I factor this? Okay, well, if I multiply the two numbers together, I get 4. So if I multiply the front and the back, I get 4. And this says I have to split 4 up in such a way that I get 2 factors or factor pairs. And so 1 and 4 are 4, 2 and 2 are 4. Now, at some point, I have to be able to add these together to get my middle term. Okay, and so I have to choose, according to, by the way, according to that second sign. This second sign says that I subtract in this particular example. And so I have to find two numbers that multiply the 4 that subtract a 3, and that's this pair. All right, now I know I have to combine them, but they're not combining just willy-nilly. They are combining 1 and 1 from front and back, and then 2 and 2. A factor from the front and a factor from the back multiply, and then you add or subtract another product of one of the factors from the front and the back. What I'm trying to get you to see here is that rather than factoring the two numbers multiplied together, which can be huge, okay, you can get up into 3, 4, 500s easy if somebody's really mean to you. And so, or even the hundreds. If you've got anything that is beyond 100, most students have difficulties finding factors. 126 was an example I did in the AC method of factoring, and it has oodles of factors, one of them being 7. Go figure. So if I can get those numbers to be much smaller, it's a lot easier to do. So let's rewrite this here and say 2x squared minus 3x minus 2. Now remember, rather than factoring, multiplying AC and BD together, those first and last coefficients, we are going to factor them right where they are. And so if I look at 2 factors to 1 and 2, 2 factors to 1 and 2. Okay, in my head, I'm going to multiply the two purple things together, and I'm going to subtract them, and I'm going to multiply the two light blue things together. I get 0. Well, that doesn't work. That can't be that way. So now, I've gone ahead and I've paired them like this. Flip it. Now take yellow and yellow and work with these. That gives me 1. And then I'm going to subtract. And I'll take, let's take red. That's sufficiently different. Okay, and let's take the red and take the red. And that's going to give me 4, and that equals -3. Oh, look, there it is. Okay, so these are my numbers. My pairs are 1 and 1. And so whenever I put a 1, I have a 1x, and then I have, now 1 and 1 is paired, so they have to multiply. All right? But I need a 2 out front. These two numbers are the front numbers. And so you can just put them right up front. You're done. Okay, now the signs must be different, but we have to be careful. You can't place them willy-nilly anymore. Opposite of my 2, since it had to multiply into this other 2 to give me 4, I put my 2. Now, the 4 is negative. The bigger of the two factors is negative. And so that has to be negative. The other one's positive. And on this one, the only thing I've got left is 1 opposite of 1. And so I put 1 out there. And so I'm done. It's x minus 2, 2x plus 1. That's the factoring. And you'll notice it was those numbers that I used up here when I factored. Okay, that's the idea behind this method. If I factor the leading coefficient and the constant coefficients where they are, we know that the middle term has to be a combination or a sum of the products of the outer ones, meaning that I have to pull a factor from the front, I have to pull a factor from the back, multiply them together. That's how I get AD. Then I have to add, according to my second sign, I have to add the other ones, the C and the B, multiplied together, the other factors that I didn't have. And that's where my other term comes from. So I combine like terms. This one's going to take some practice. It's very easy to see where it comes from and like, oh, duh, it has to work. But you can have a lot of different pairs of things, particularly if you have a number like, say, 24 on the end, because 24 has oodles of factors. It had factors of 1, 2, 3, 4, and 6. Well, 1, 2, 3, and 4, really, because then 4 and 6. But you have to develop factor pairs. And so if you have two relatively prime numbers front and back and they're big numbers, you're going to get a lot of factor pairs if you try to do it through grouping. I'll give you a video where I do 3 examples of these. So just watch for that.